Good morning, good evening, good afternoon, or whatever you're supposed to say. I got strong pointed out from LM that I'm not supposed to do any commercial things here, only one thing, and that is that I have my whole Swedish team is here. So Patrick and Johan, can you stand up? So if there are any, very difficult questions here, these are the guys who can answer it, not me, because I'm the manager. All right. So this is sort of a topic on it. I'm not going to ditch too much into the MPLS. I'm not going to teach too much into IP version 4 because, if you not say anything about IP version 6 in this crowd, I guess you get beat up in the yard. What I'm going to talk about is how you're going to adapt path and bandwidth in a large data center. How many people here run such a large data center? Raise your hand. Fastly, I know that you run a data center, right? All right. Everything is large, right? This is large, right? Okay. All right, let's go. So based on performance, in a data center or any kind of network, there's a lot of statistics that can be collected. We like S-Flow, but you can run N-Flow or IPFix or any you desire. That statistic can go from mostly any network element in your network. Telemetry, which is sort of the talk of the town, that is statistics that gets from your control plane. That sort of replaces SNMP. Then, of course, you can get all the statistics from your servers, which is the legacy TCP statistics and stuff like that. And in the end, if you want to have something reactive, well, it's logs and alarms. All the way in the network, you can collect these pieces, but you have to do something smart with it. And, the previous sessions was partial about that. Excuse me. So this is a simple output of S-Flow statistics from a single A2 switch. Because if you're on an extension, it knows equal amount of IP as an IP router. So you can get all kinds of statistics. So that works with Facebook and Google and all those guys. These are very useful for the east and west traffic, where the servers talk to each other. Then you're interested to see the traffic flow between each host. This is output where you're more interested of the south to north, which is actually traffic going to leave the data center, because then you're interested in what prefix, because those prefixes are tuned to a BGP edge box. So as you can see, there's tons of stats that you can track. How much of volume, who talks to who, and etc. There's no excuse that you don't know what's going on in your data center. What are the possible bottlenecks in a data center? Well, could be leaf and spine. That's a usual thing. You can't TCP incast because suddenly mostly every traffic goes to one specific server and not to, despite that you try to load up your application in your whole data center bank, there still are a few servers that get hacked out most of the TCP sessions. You can essentially prove through bandwidth on it here. Bandwidth in a data center is relatively cheap. And if you don't know it, I happily sell you one. BDP Edge is a little bit of a tricky question because that is depending on the peering contract. When you're going to leave your CDN data center, how much can you get from Telia and Tele2 and Telenor and all those guys, right? So it's a little bit depending on the bandwidth there and also how their networks look like, which is sort of out of control, right? You have to rely on their AS path actually is not fooling around with you. So that is a little bit difficult piece to troubleshoot. And then, of course, you have the server, which means that this is a TCP stack, all kinds of data that you have related to your whatever Linux variants and whatever you're running. So all of these pieces are where you can have bottlenecks. And what I will focus mostly is on the path to the BGP edge. So in a data center, the quality is not ping or trace route between servers, right? It's not how you troubleshoot a WAN. Oh, I can reach that server, get along with it. That says nothing, right? The whole quality of a server is based on a TCP statistic. The whole quality of your data center, how TCP behaves in your data center. That's it. Ping and trace doesn't mean a jack shit here. It's all about the statistics from the server. So if you have retransmission, duplicates ACK, and so forth from the server, you need to do something about it. Could be that you have ECMP problem in data center, which is most unlikely. Could be your BGP edge peering, which I'm going to talk a lot of. Could be a DDoS attack. Or it could be this yearly event when Svenska Ridsport gets Jerry preset all the time, right? So these are the challenges when you're going to troubleshoot a data center. this is not a lesson about TCP stack. I guess the whole point with it is that everyone assumed that you guys are full flowy with Mikael Abrahamsson's talk about routing header or not routing header IP version 6. I assume that you know your TCP lesson. So I'm not going to try to explain the difference between certain amount of Linux dialect. Some depend more on RTU, others on duplicate action. I just assume that you have read a book about it or talk with someone that knows it. So, but the whole essence is based on this, right? This is from the server, how the performance is. I'm assuming that you actually is interested how TCP works. So there's all kinds of things that you can do. Once those scripts are identified at a certain server doing a lot of duplicate acts, you do need to do something with it. And one of the most common things is that you automatically start a packet capture, because you want to tail down what sessions are in trouble, and thereby you can trace what's the destination of it. So this is one example of it. You can see that you have pretty much duplicate acts for more or less what you send, right? Which means that you have retransmissions. What to do about it? So after a lot of troubleshooting, you decide to swap your BTP edge, and then your duplicate acts going down to levels that you expected. So these are the stuff from the server that you see actually a reactional change. So what I will talk about is the difference between this picture and that with regards to the BTP edge, what they actually have done to solve it. First, bandwidth control. So it's pretty easy actually to build a good data center. You have your leaf and spine topology. I know there are vendors that have been trying to build circles and collapse backbone or all that stuff. Wish them good luck. It doesn't work. The only thing that works is a leaf spine. Next thing is to be aware of the over-provision. So over-provision is usually based on what you do on your leaf, which is where you connect your servers. So if you have more access ports than uplink bandwidth, you have over-provision. It's easy as that. So if you don't accept over-provision, that is something that you need to do. And again, there's no excuses for that. There are most switch vendors that can supply you where uplinks can match your access ports. That means that the over-provision from the start, you can figure out all about that. The third pillar here is buffers. I come from the routing side before I jump into data centers, so buffer for me is sort of self-explainable. I know that others try to say you don't need buffer. We do magical hacks where we prioritize SYN and all kinds of things. The only result with that is that you have lots of equal bad sessions, right? The only thing to solve and guarantee performance is buffers. So no difference to their server. They will never run anything if they didn't have buffers, because buffers is the name of the game. Sorry about that. I constantly have this picture when I'm running. It is essentially, this is how it goes. You build a leaf spine, and you route. Essentially, there are three things to learn in a leaf spine. You route, and you route, and you route. Or you route. That's it. Everything works with the IP. Everything works with routing. Nothing works with more than 3 nodes in a triangle if it's laid 2. That's a fact. The second pillar is ECMP. ECMP has nothing to do with bandwidth, really. ECMP is redundancy. Because if you have a setup, it means that you have active-passive. Your passive will never survive once you need it. With a leaf spine in an ECMP, you know that it works because you're using it all the time. So if you're building it in layers with ECMP, you know that your convergence will be that. You're not just wishing that, OK, if I switch into my alternative path, maybe it works. So ECMP is redundancy in a large data center. Right. So why do you need path control if you have this well-designed leaf and spine? It's a BTP edge, because there the bandwidth is costly. That's where you connect your peering, because that's what traffic is going to go out of the data center. So that is where you need most of the tuning. Not really in the east and west traffic. That's very deterministic. You can throw as much bandwidth on it as you want. So let's say that you listen to my advice, you route, and using a protocol that always makes sense, which is sort of BGP. So what is BGP bandwidth aware? No, you pick a path. Has really nothing to do with bandwidth. All right? You turn on ECMP. Is it still bandwidth aware? No, it's path aware, right? It doesn't have any knowledge and differentiation if you have a 100 gig or a 10 gig in the exchange traffic. It simply doesn't know. All it does is that it has equal amount of cost to reaching that destination. So you can play with more specific routes, which means that, okay, I'm going to load balance in transit because I have the same speed. But for my private peering, I will select the ones that have bigger pipes or smaller AS path or whatever. But it's still not bandwidth aware. You can also do more advanced stuff, which means that you bring in all those statistics that I was talking about, measuring, and you try to balancing your source node traffic by injecting longer prefix routes. You artificially create something like third-party next stop. And that means that by constantly balancing the network, you maybe can get full utilization. The last advice here is actually invade something to BGP that calls weights. That is that you have bandwidth as a topic, as a BGP attribute that you advertise down to your leaves. So in this example, that is that you have a community for my 10 gig private connection and another community for my 100 gig connection, and I advertise down south into my data center. And this is the well-known community. Based on this, the leaf can then proportion flows, which is 10 times more flows, 10 times more session in the hash goes to the one that has more bandwidth. Now you have at least your chance to balance based on how your BGP edge looks like. Is this a standard? Yeah. I've been working in Cisco and Juniper and Arista, so I guess I've spent my whole career trying to make your life miserable. But all of these vendors have BLMD community, which means that I see that as a standard, right? Then, what each vendor do to infect your flows locally, that is vendor dependent. That's up to you to find out. Right, now we're talking about bandwidth, now we're going to go into path. Source routing is destination routing. All I've been talking so far is based on destination routing. But if you have the previous problem I showed you where I need to swap the BGP edge and also the path to it, then I need to bypass how the routing looks like in my data center or in my network. And that is source routing. I guess showing our IPv4 header here makes half of the people that are V6 geeks here not happy, but there's a header in IPv4 that allows doing source routing. I've never seen anyone really using it. So if anyone has used this, I would likely take a picture of it outside and document it. IPv6 has all the capabilities of doing it, right? Because it's just called next header. But that sort of has an extendable security flow. So I guess someone will take me to school here, but honestly, I don't know any Linux implementation that has to turn on by default. So that path also is sort of a challenge. So what to do then if I have an IP network and I want to control my paths? In V4, we'll talk about this sort of a 40-byte header, which means roughly somewhere between 8 or 9 hops, which is pretty good. In V6, you could do more as you like, but this is a dead end. I don't know anyone that's using it, particularly not in a data center, based on just an IP packet. Not even Peter Löfberg would try to do this, right? So what to do? So this is an example of a very cloud player, where it's not just a 2-tier or 1-tier, it's not just a leaf and spine, right? There's a whole bunch of leaf spine connected by a super board and a whole bunch of BGP edge. So what they need here is to balance the traffic between the planes. That's the path control. By the way, this picture I got from Peter Löfberg, actually, it's one of his famous ones. MPLS sort of supposed to be the answer to everything. And one of that protocol that really is the most implemented one is, before that, it's going to take the action. Is anyone here that doesn't know the MPLS push and swap action? No, you know it, right? Of course you do. So RSVP. How many in here have an RSVP network? Nordinet, do you have RSVP? Yes. Oh, jeez. All right. You have my apologies. I hope I haven't convinced you to doing that. All right. He's doing a job at the cost of extremely resourcing heavy. It's a protocol designed 30 years ago for having between voice controllers and RTP packets and signaling and stuff like that. So in 2019, try to do something better. And one thing of that is segment routing. And I just had a discussion in the hallway here that segment routing is link state. No, has nothing to do with ISIS or USBF or BGP. Segment routing is the concept of doing it. What segment routing is that you have a SID, and that see this as you define your network. You have a network, you have a management addressing space. See that's a label range. And then you have an SID. See that's a loopback, right? Am I still allowed to have 128 in a V6 network, Mikael? Or should I have 64 for that, or? Yes, yes, all right. Thank you, all right. I will still use 127 on links, so it doesn't matter what you guys are saying. All right, whatever. So the good thing with it is that essentially it's an IP network, right? It's using IP protocols like ISIS, USBF, or BGP to advertise segment. And a segment is unique, like an IP address. So if the destination is one IP address, the destination will be that SID. So the SID is unique in the network, but there's no need for any advertisement of labels in between. So you take away all those LDP and RSV riffraff, where you're typing something and you get a 4 or 5 A4 pages long about all the labels you have in your network. So let's see how it works. Also, one thing with segment routing is that it does ECMP. That is why we that build large data center likes it. RSVP doesn't do ECMP. It does a path. So if your routing is ECMP, segment routing will be ECMP. So how many in here knows in depth about ISIS? Raise your hand. So segment route is just yet another TLV in the ISIS protocol. So you get a range, and your prefix SID is sort of your loopback. Now we have created a labeling path, and the awareness of your segment routing will be like awareness of routes in ISIS network. Surely, Peter, you would like this, right? This is labels, but using an IP protocol. You can't have nothing against this. There's absolutely nothing, right? There's no LDP, there's no RSVP, there's ISIS there that just advertise our range. Say yes now, right? He says yes. So now everyone in the community is allowed to have a segment routing. The way to tune the path, we're using BGP, of course. So BGP LU. So BGP LU then sets a stacked path. Then you can tell, in order to go this direction, use these labels, and thereby you will take it that direction. And again, Peter, you can have nothing against this, right? It's BGP that advertise just an IP to a tag, right? He smiles, looks good. So, and also, since I've been doing mostly data centers, we don't really do link state protocols in those, right? We just do BGP. So you can replace ISIS with BGP SR, which means that you only, on your link-to-link BGP peering, you advertise these segments. Surely this is way better than doing RSVP protocol, I think. And Peter also, by the way. So it's the same thing. In the forwarded table, you will have an IP, and you have a segment. You can call it label if you want, but I prefer to call it segment. Right, 10 minutes to go. Is it lunch the next session, or is it another speaker? Another speaker, right? I will hold my 10 minutes then. Else I get kicked out. So there's various ways of doing it, right? You can have those dynamics called protocol to change the path to the BGP, or you can do it statically. So many of those cloud vendors, they run BGP all the way down to the servers, and from the server, they inject this label. And I guess they don't need the fancy ISIs, but BGP-LU they have nothing against, right? So this is one way of doing it, which is, by the way, Fastly is doing. So I think David Barossi is somewhere down there. He's a bird and ponytail, and well, he looks like how internet geeks supposed to look like. No, not like me, right? The other alternative one is that you're using the dynamics on the protocol, which means that your data center is maybe also connected to DCI, so it also is an operator network or something like that. Then you start the whole thing from the leaf, right? And then you're using BGP-LU to change the path. But here you have your ride on the dynamics on the routing protocol. So there's two ways of doing it. So let me very shortly show you two examples. Consider this network. I didn't have time to swap those V4 addresses to V6, but I will do that next time. We'll just create a label for it. So I'm not going to get smirky questions from the V6 community here. But let's say I have here, the most key part here is I have two BGP exchange points here. One is 1 gig and one is 10 gig. I need to use them both in order to utilize my peering and my north and south network. It doesn't matter if certain links, like in this case, goes down, because the pipes between the BGP boxes is rich, because it's a data center. I have absolutely no problem in just throwing 100 gig links there, right? But the traffic needs to leave both of those data centers. The way to do that is how? If this were just an IP network, the traffic to both of these BGP networks would stop on this device here, right? Because if IP cracker come there, it's going to go to that destination. He will not send it up there, right? Everything will go up there, so that peer will not be in use. There's no way you can do that except using a label. So can you guys see it from the back? Patrick? Down? Oh, fuck off. You're not going to get the bonus this year, that's for sure. All right. So first one is the route, right? And then what you can see is I have a link bandwidth. The link bandwidth is something I'm going to explain earlier. We will see it, how we're going to handle the hashing towards the destination. And then they have a BGP next hop, and it is the BGP next hop, this SID, that's going to do all the job. And the way to do it is that I allocate a SID, a label, to those BGP next hops. So when this guy is going to push packets, despite that it now has an architecture, which means that more or less everything traffic should leave just one BGP edge, is because I'm doing a label, right? So a label is going to push to it. So half of the traffic, according to the hashing, will go to the upper BGP port, and next, all the rest with this sort of 10 times more will go to lower. And the way that this BGP community works is that it's not an exact, you can come up with any funky number you want, right? The only difference here is that one is 10 times more. That means that 10 times more the sessions will go to the one that has higher bandwidth. So now you will utilize both of those BGP edges. And the way to trick it is because the destination here is a segment. It's not just the BGP next hop that's an IP. 55, right? A very common in data center is that you don't run full feed all the way down to the leaf. You can play this trick exactly the same way, but you generate a default route down your network according to those hashing like the BGP community. So this time the result will be exactly the same. A last scenario here is that I want to change the path. You remember when I had issues with duplicate transmissions because my BGP edge needs to change, but I was uncertain if it was the BGP edge or the path to it. So let's change all that. The way to do that is by, for instance, using a controller. So what the controller here is that it changes the path, the BGP next hop, and the labeling out, and it forces, without doing very heavy routing changes, forces the traffic to use only one. And this is also one of the scenarios that can only be done if you're using a label here, and essentially I call it a segment. So what you program down here is a path where this node here, it forces him to take this explicit path. So this is as close to RSVP-T you can go without this funky RSVP reserve and state change. Everything here is done from ISIS or BGP. Right. 5 minutes to go.
Perfect.
Questions?
So we have 5 minutes, so we have some time for some questions for Peter, if anyone dares. Right at the front.
Yeah, sort of expected.
So you forgot the Belgian accent.
All right. Again, I'm in the hallway. I'm the good-looking one. And my teammates there, they know everything about segment routing and preferably better. And of course, you can talk to Peter Löper. He's now also a champion. Thank you very much.